Welcome to lesson 3.2, where we're going to talk a little bit more about derivatives of exponentials and logarithms. So before we get started, let's review what we know so far. We know that the derivative of e to the x is e to the x. We also know that the derivative of ln of x is 1 over x. And quick review, ln of x is log base e of x. That's what ln means. It stands for the natural logarithm. Now, so far we have only learned the derivatives of these specific functions. We do not yet know how to do the derivative of, say, 3 to the x. We can only do e to the x right now. And we don't know the derivative of log base 5 of x. We can only do log base e of x, or ln of x. So that's what we're going to explore a little bit today. But before we do so, we need to understand first that the chain rule that we learned in last lesson also works with ln and exponential, the mommy and the baby. So let's do a couple examples right here. Let's say I have e to the x squared plus 2x. I could do the chain rule with this, where I take the derivative of the mommy would be e to the u, and the derivative of e to the u would just be e to the u, just like we said up here, times the derivative of the baby. So the derivative of x squared plus 2x would be 2x plus 2. And then I plug the baby back in. So e to the baby times 2x plus 2. Right there. And that's what this rule says right here, is e to the u times u prime. The mommy times the derivative of the baby. So I can also do the same thing with ln. Let's say I want to take ln of 5x minus 3. This is the chain rule as well, where I'd have the mommy of ln of u. So I take the derivative of the mommy, which is 1 over u, times the derivative of the baby, which would just be 5. And then I plug the baby back in. So 1 over 5x minus 3 times 5, which I could simplify to 5 over 5x minus 3. And that's where this rule comes in. The derivative of the baby over the baby. That's what that ended up being. The derivative of the baby over the baby. So that's the chain rule applied to exponential and logarithms. Now let's start to explore if our base isn't e. So right here, a to the x, where a is a number. So this is now 3 to the x, 5 to the x, 2 to the x, anything to the x, not just e. And we need to figure out what the derivative of that would be, because it's not the same as e to the x. So what we're going to do right here is, it says first step, do the inverse property of exponentials and logarithms. So I added e to the ln because I know from the previous chapters that those will cancel out and I end up with my a to the x, what I had. So I'm going to add those in. And the reason I'm adding that in is because now, step 2, I can do my log property where I take my exponent and put it in front. So I took that exponent and put it in front. Now, step 3, I can use my chain rule. So this is e to the u. So I would take the derivative of the mommy, which is e to the u, times the derivative of the baby. So here's my baby right there. And remember, a is a number. So this is x times ln of, say, 3. So that means this right there is all just a number. ln of a, I could put into my calculator and get a number. So the derivative of that would just be ln of a. if I can write. And then I'm going to plug the baby back in. So e to the x ln of a times ln of a. Now, step 4, I'm going to do the same log property, but in reverse. So I'm going to take that x in front, and now I'm going to move it up again. So I'm going to have e to the ln of a to the x times ln of a. And then step 4, now I cancel out my e and my ln, so I get a to the x times ln of a. And that's our derivative rule for when the base of the exponential is not e. And you can see that right here. And it does also still work for chain rule. So chain rule, this part is the derivative of the mommy, and then this is the derivative of the baby. They just reordered them, that's all. So if we want to write it like this, derivative of the mommy times derivative of the baby. That's our chain rule for what the rule we just came up with. Okay? Now let's do it when we have a log of a different base. So right here, log base a of x, where once again, a is a number. So this could be log base 2 of x, log base 10 of x. ln is log base e of x. So now we're doing other bases. But we're going to start with step 1, my change of base formula. If you remember, that means I could take any log base anything and change them to ln of x over ln of the base. So that's my change of base. Step 2, since ln of a is a number or a constant, I can pull it out of the derivative. That's that scalar multiplication rule. So this is a number. I can type that into my calculator and get a number. So I'm going to pull it out of the derivative. And now I can take the derivative of ln of x, which I know is 1 over x. So that gives me my derivative rule, 1 over x times ln of a. They just reordered it a little bit. And then once again, you can apply a chain rule to that, where here's the derivative of the mommy, derivative of the baby. So those are all of our new derivative rules. In the next video, we'll practice them.